Now see here this arrangement of numbers. 2, 11, minus 6, 0, 5, minus 37, 8, 2, 61. Now in this arrangement, we cannot tell why the particular number is at particular position. Why the particular number is at particular position? Because we cannot find any rule to obtain the next number. There is no any rule to obtain next number. So this arrangement is also sequence. But we are going to learn the sequence which have rule to obtain the next number. We will study those sequence. Now we will study the next the terms in the sequence. Now see here, the first sequence is here. Suppose sequence is like that. T1, T2, T3, T5, T6 and so on. T1 like that. Now this is sequence. And these are the called terms in the sequence. This is first term, second term, third term, fourth term, nth term, like that. In general, the sequence is written as in curly bracket Tn. Sequence is written in this symbol Tn. That means this sequence Tn is equal to T1, T2, T3, T4 like that. In this way. These are called the terms in a sequence. First term, second term, third term, fourth, sixth, seventh, eighth, like that. Nth term, these are like that. Now see here, in this sequence, for example, in this sequence, 9, 15, 21, see here. In this sequence, first term, that means T1 is equal to 9. Second term, that is T2 is equal to 15. Third term, 21. Fourth term, like that. In this way, the terms in the sequence are written like this. So here, in activity, on page number 56, in first activity, such 3 examples are there. So here you have to write the number of terms T1, T2, T3 and you have to fill the boxes here. Now in activity 2, we have to check the rule, or we have to find the rule by which we can obtain the next term from its preceding term. So for in activity 2, this example is given. Suppose Same the rule for the terms of the sequence. Look at the arrangement on the next page and fill the empty boxes suitably. Now see here, I will take here second example. Your first term is 6, second 12, third term 18, fourth term 24. Okay. Now see here, in this arrangement, we will find the rule. If you observe the numbers, there is a difference of 6. That means these are the numbers of multiple of 6. That means if we add 6 in the preceding number, then we will get the next number. That means here 6 plus 6, we will get 12. Now this 12 plus 6, we will get 18. 18 plus 6, we get 24. 24 plus 6, we will get next term 30. 36 plus 6, we will get next term 36. Like that. And now see here, one more example here. Fourth example. In fourth example, and the first term is 4, second term is 16, third term is 64. Now here, if you multiply the preceding term by 4, we get the next term. That is here 4 into 4. We get 16. 4 4s are 16. 16 into 4. We get 64. 64 into 4, we will get the next term. Like that. $64 multiplied by, we will get 256. Now again if you multiply 256 by 4, we will get the next term. That means here the rule is that to obtain the next number, we have to multiply by 4 to the preceding term. This rule. Now in this, and here the next is six. Now here in 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, like that. Now here in first sequence, to obtain the next number, we have to add a particular number in a previous or in a preceding number. In second example, to obtain the next number, we have to multiply by a particular number to the preceding number. So in this case, here the first, this arrangement 6, 12, 18, 24 is called arithmetic progression here, and this, in this example 4, 16, 64, 256, this arrangement or this sequence of number is called geometric progression. It is called geometric progression. Now in this standard we will study only this arithmetic progression, and in sixth example here, this example is neither arithmetic progression nor geometric progression. This is not, this sequence is neither a arithmetic progression nor geometric progression. So here in these examples, in activity 2, example 1, 2, 3 and 5. Example 1, 2, 3 and 5. These are arithmetic progressions. These are the examples of arithmetic progressions. And sequence 4 is not the example of arithmetic progression. And sequence 6 is neither arithmetic progression nor geometric progression. Now see here, three examples are there. In first sequence, 100, 70, 40, 10, minus 20, minus 50. Now see here, if we add this is the first term, second term, third, fourth, fifth. Now if we add if we add minus 30, that means 100 minus 30. We get the next term. Okay. Now if we add minus 30 here, 70 minus 30 we get 40. Again if we add minus 30, minus 30 we get 10. Again if we add minus 30, that means minus 30 plus 10 we get minus 20. Again if we add minus 30, so here we get minus 50. That means here, if we observe these numbers, there is a difference of 30 between two successive terms. In two successive terms, there is a difference of 30. That means this difference is constant. 30, 30, 30, 30. That means here 100 minus 70, 30. 70 minus 40, 30. 40 minus 10, 30. That means difference between two successive terms is constant. Now here also, in second example here, if we add, in second example, if we add 3 here, plus 3. Here we get minus 4. Minus 7 plus 3, minus 4. Minus 4 plus 3, minus 1. Minus 1 plus 3, plus 2. Two plus 3 plus 5, like that. Now in third example, here all terms are similar. 4, 4, 4, 4, 4 and so on. That means if we add 0 in each term, 4 plus 0, we get 4. Again, 4 plus 0, we get 4. Again, 4 plus 0, we get 4. So here, in first example, here the common difference, this difference is common. The common difference is minus 30. In second example, the common difference is 3. And in third example, the common difference is 0. That means the common difference may be negative, it may be positive, or it may be 0. If the common difference is constant in a sequence, if a common difference is constant, that means common difference between two successive terms is constant, then that sequence is arithmetic progression. That is good. That means all these are arithmetic progressions. So here, if the difference between two consecutive terms is constant, then it is called common difference. The constant difference is called common difference and is generally denoted by letter D. Okay, now we will see the definition of arithmetic progression. So, arithmetic progression. In the given sequence, if the difference between two consecutive terms, that means Tn plus 1 minus Tn is constant, then the sequence is called arithmetic progression, and in short it is written as A dot P. That means here Tn plus 1 means, that means, and T minus Tn, these are two consecutive terms, and if the difference between these terms is constant, then that sequence is arithmetic progression. Now in arithmetic progression, generally the first term is denoted by A, first term T1, and common difference D. And if we know the first term and common difference, then we can write that arithmetic progression. That means the first term is A, first term A, T1 is equal to A. Now second term, to find the second term, we will add the common difference in the previous term. That means A plus B. After adding the common difference in previous term, we will get the next term. To find the third term, T3, we have to add common difference in second term. That means T2 plus D. that is equal to a plus d plus d, a plus 2d, and t4, that means t3 plus d. So t3 is a plus 2d plus common difference d, that is equal to a plus 3d. So in this way we can find all the numbers, that means a plus d, a plus 2d, a plus 3d, and so on. A plus 4d, a plus 5d, the first term, second term, third term, fourth, fifth, like that. In this way you can find that arithmetic progression. Now practice set 3.1. Question number 1. Which of the following sequences are AP? That means arithmetic progression. If they are AP, find common difference. Example 1. The sequence is given 2, 5 upon 2, 3, 7 upon 2, and so on. Now see here the first term is A, that means T1, 2, first term. Second term is five upon 2. Third term is 3. And T4, that means fourth term, 7 upon 2. Now we will find the difference. T2 minus T1. Five upon 2 minus 2. That is equal to 5 minus 4 upon 2. That is equal to 1 upon 2. Now T3 minus T2. 3 minus 5 upon 2. That is equal to 6 minus 5 upon 2. And T4 minus T3. 7 upon 2 minus 3. 7 minus 6 upon 2, that is equal to 1 upon 2. That means here common difference is constant and it is 1 upon 2. 1 upon 2, 1 upon 2, 1 upon 2. That means here common difference therefore here if the common difference is constant, then the sequence is arithmetic progression and common difference is 1 half. So answer is the given sequence is AP. And common difference T is equal to 1 half. Similarly, you can solve third, fourth, fifth, sixth. Now I will take directly seventh example. Now see here. Here T1, first term, 3. Second term T2 is equal to 3 plus root 2. Third term T3. And fourth term T4. Now difference. T2 minus T1. T2 is equal to 3 plus root 2 minus 3. 3 minus 3 we get 0. Here remains root 2. Now T3 minus T2. 3 plus root 2 minus 3 plus 2 root 2. And here is also 3 root 2 now T3, 3 plus 2 root 2 minus T2, 3 plus root 2. Okay. Now remove this bracket. Here we get here 3 plus 2 root 2 minus 3 minus root 2. So here we get 3 minus 3 0 and 2 root 2 minus root 2 we get root 2 here. So here also common difference is root 2. Now the third T4 minus T3. 3 plus 3 root 2 minus in the bracket 3 plus 2 root 2. After removing this bracket we get 3 plus 3 root 2 minus 3 minus 2 root 2. 3 minus 3 0. Here we get 3 root 2 minus 2 root 2. 3 root 2 minus 2 root 2 we get root 2. Now here also difference is root 2. That means here common difference is constant, root 2, root 2, root 2. Therefore, the given sequence is AP and the common difference is root 2. Now question number 2. Write an AP whose first term is A and common difference is D in each of the following. Example 4. So see here, first term is given minus 1.25 and common difference is 3. That means here first term T1 is equal to A minus 1.25. Now second term, to find the second term T2, so that means T1 plus D, that means A plus D, that is equal to minus 1.25 plus 3. So here we have to subtract 1.25 from 3. 10 plus 5, 5. 9 plus 2, 7. Here 2 plus 1, 1. That is equal to 1.75. This is second term. Now third term, T3. That is equal to A plus 2D. Or you can direct this second term is here 1.75. Add common difference here, you will get that is equal to 4.75. And you can get T4, 4.75 plus 3, 7.75. And therefore, the AP is here first term minus 1.25, 1.75, 4.75, 7.75, and so on. In this way, you can find all the terms of the sequence. Question number 3. Find the first term and common difference for each of the AP. Example 1. Arithmetic progression is here 5, 1, minus 3, minus 7. So we have to find the first term. That means here 5 is the first term. That means here T1 is equal to A is the first term 5. Okay. Now we will find the common difference here. So here T2 is equal to 1. T3 is equal to minus 3. T4 is equal to minus 7. That means here first term five. Now the common difference. T2 minus T1. 1 minus 5 minus 4. Or if you take T3 minus T2 minus 3 minus 1 minus. Or if you take T4 minus T3 minus 7 minus 3, that means minus 7 plus 3, you get minus 4. So common difference is minus 4, and therefore answer is, therefore first term is equal to 5, and common difference D is equal to minus 4. So in this way, from practice set 3.1, some examples we have solved from question number 1, 2, 3. So remaining examples you solve by yourself, and that is for your homework. And in next period we will study the nth term of AP.